let's try example number 6, where we're giving you a function that's already in standard form for graphing, but we still want you to find some information about it. So the first question we want to ask you is, based on h of x equal negative 3 times x plus 1 squared plus 2, what is the vertex? Now keep in mind that standard form for a quadratic for graphing looks like this. H of x is equal to a times x minus h squared plus k, with the understanding again that hk is the vertex. We have our a value, which is fine. We have our x value, which is fine. And we also have our k value. But what differs from our h of x when we're comparing it to the standard form for graphing is that we have subtraction. So what we're going to have to do is we're going to have to rewrite our function h of x using subtraction. So we can call that negative 3 times x. Now remember, addition is the same thing as subtracting a negative. So I'm going to call that x minus negative 1 quantity squared plus 2. And so in that manner, we now have subtraction, which is what we have in standard form, which is over here. So what this does is this tells us that we have a vertex of negative 1, 2. So putting it in that standard form gives us that vertex of negative 1, 2. The next question is, does our vertex represent a maximum or a minimum? Well, we can use our a value to determine that. Here's our a value. It's negative 3. Now, if a is negative, that means we have a sad parabola. Picture a sad parabola. It looks a little bit like this. And that means that our vertex represents a maximum. If we have a sad parabola, our vertex is a high point on that graph. So we have a vertex of negative 1, 2, which is a max. In terms of axis of symmetry, we have an axis of symmetry at x is equal to, and that's the x value of the vertex. We have an axis of symmetry at x is equal to negative 1. Let's move on next to our y-intercept. Now the definition of the y-intercept is when x is 0. So I'm going to go back to my function, which is h of x is equal to negative 3 times x plus 1 squared plus 2. And we're going to substitute in 0 for x. We get negative 3 times 0 plus 1 squared plus 2. That's the same thing as saying negative 3 times 1 squared plus 2. That's the same thing. Well, 1 squared is 1 times negative 3 is negative 3. So we have negative 3 plus 2, and that's the same thing as saying negative 1. So we have a y-intercept at 0, negative 1. For our x-intercepts, now for the x-intercept, here's when we substitute in 0 for y. The definition of the x-intercept is when y is equal to 0. We don't have y, so instead what we're going to do is we're going to use h of x. Remember that h of x is the same thing as saying y. So we're going to substitute 0 in for h of x, and we get 0 is equal to negative 3 times x plus 1 squared plus 2. And now we just have to solve for I'm going to move this down a second. Now we have to solve for x. So the first thing we're going to do is we're going to subtract 2 from both sides of the equation. It's going to help us begin to get x by itself. We have negative 2 is equal to negative 3 times x plus 1 squared. We want to get that x out of the square term, but first we have to divide both sides by negative 3 because there was a coefficient of negative 3 attached to it. So when we do that, that gives us 2/3 is equal to x plus 1 squared. To get rid of the squaring, we're now going to take the square root of both sides. And don't forget, when we take the square root, we need that plus or minus symbol. We have plus or minus the square root of 2/3 is equal to x plus 1. The last thing we have to do to get x by itself is to subtract 1 from both sides of the equation. So we have two x-intercepts. We have x-intercepts at negative 1 plus or minus the square root of 2/3. We'll talk about what that means in a second. Now for this last part of this question, I want us to put all this information together and to come up with a nice comprehensive graph that kind of ties everything into each other. The first thing when I'm graphing that I'm going to do is I'm going to go to the vertex. Remember, we had a vertex at negative 1, 2. So here's my vertex at negative 1, 2. The vertex right here. Now remember that this represents a maximum. So knowing that this represents a maximum, that means that the two arms are going to fall down onto its sides. So let's figure out what the y-intercept is next, because that will tell us where we're going to hit on the y-axis. Let's see, we had a y-intercept at negative 1. So I'm going to go to negative 1 on my y-axis, which is right here. Okay, so one of our arms is going to go down like this. Now remember that these guys are symmetric about that axis of symmetry. Here's our axis of symmetry. It's at that line x is equal to -1. So we should have a carbon copy of this on the other side, which looks like this. Okay, the last thing we need to do is we need to think about what the x-intercepts are. Now remember, we have two of them. We have -1 plus the square root of 2/3, and we have -1 minus the square root of 2/3. So this guy over here, this is represented by -1 minus the square root of 2/3, because it's -1 and then we're subtracting something, so it's going to be a little bit to the left of that. And this guy over here, this guy is represented by -1 plus the square root of 2/3. And what we're going to do is we're going to use calculators to help us estimate them. So when I get on my calculator, I'm going to type in -1 plus the square root of 2 divided by 3. And that gives me a decimal approximation of -0.18. And you can see it's really close to 0, but on the left side of it, so that makes sense. And then I'm going to type into my calculator -1 minus the square root of 2 divided by 3. And for there, I get -1.8. And that's what this guy represents right over here, represents at -1.8.